Today we will discuss KROS, a semiconductor automation system. KROS controls electric water heaters, eliminating their significant drawback, inefficiency in heating water. It offers a solution to this common issue: the need for careful preparation of the coolant, so-called water treatment. So if you purchased an electric boiler with the KROS automation system, you won't have to worry about managing the water treatment process. Although you are using ordinary tap water, this automation offers numerous advantages and distinctive features that make it undeniably the best option on the market, setting it apart from the competition. But let's begin by addressing the name. Decrypt everything in the proper order, step by step, starting now. KROS, controller, regulator, heating system. Numbers following the word KROS. These numbers indicate the nominal and commented load power. Single-phase KROS 5 and KROS 10 have a load power of up to 5 kilowatts and up to 10 kilowatts respectively. Three-phase KROS 15. Crossing 25, 50, 200, and 500 are all crossed in this sequence. Accordingly, the three-phase load consists of 15, 25, 50, 200, and 500 kilowatts of power. Now about the main thing. KROS is a semiconductor automation. What does this mean? So this means that the voltage to the water heater is supplied and disconnected, not via the contacts of any relays or contactors, and through powerful semiconductor devices. Depending on the model, these can be transistors, thyristors, or triacs. And thanks to this, KROS has its main advantages. In the beginning, there is absolute silence. The load switching process remains completely silent. Recall the way the contactors click in the brain, particularly during the nighttime. Secondly, durability and reliability. No contacts, nothing wears out or sticks, like with contactors or RL. Third, the semiconductor device operates within a wide voltage range and is controlled by a very small voltage from the internal power source of the automation system itself, providing precise and efficient control. This coil does not overheat or burn out at high voltage, nor does it fail to close contacts at low voltage. It is not a contactor coil, so it does not experience these issues. However, it is beneficial to have a functional heating system that can handle substantial voltage fluctuations in the network. The fourth and most significant, the capability to smoothly adjust the voltage supplied to the water heater is of utmost importance. The contactor has two states: on, where all voltage is supplied to the water heater, and off, where no voltage is supplied and has been turned off. The water heater is currently turned off. A semiconductor device has the capability to function as a water tap. The more you open, the more water flows through it. This property is utilized in all connections for the efficient functioning of an electrode water heater with tap water. That is, to eliminate the primary disadvantage of an electrode boiler. And this is not a myth. I will now explain how it operates. Let's analyze the picture. This is a truncated block diagram of the single-phase automation KROS system. Power supply ensures stable power for all electronics within the KROS system's architecture. The microcontroller is based on signals received from temperature sensors and control devices. It issues control commands to execute mechanisms and blocks accurately and efficiently. To enable automation and external executive mechanisms, a current stabilizer is utilized as one of the executing blocks, playing a vital role in maintaining stability and ensuring smooth operation. The current stabilizer, in turn, controls our semiconductor device, acting like a tap. The device is represented on the diagram as a 7-segment display and is used to regulate the power of your water heater. The power of your water heater is currently determined by a sensor that measures the electrical current. The current sensor signal is transmitted not only to the current stabilizer, but also a microcontroller in order for you to see the current value of the current on the display, and in case of any emergency situation, for example, a sharp increase in current due to a voltage surge in the network, to disconnect your water heater from the network. I have already mentioned that this is a truncated cross-block diagram. Control blocks for pumps, control block for the second boiler, and other scheme parts are not depicted here. We are currently in the process of evaluating the primary function, which is power regulation. This is how it works. We supply power to the KROS. The microcontroller, based on signals from temperature sensors and other control devices, issues a command to the current stabilizer to generate heat and maintain stability for optimal performance. In addition to its primary function, the current stabilizer also offers a remarkable benefit by ensuring a smooth startup for your water heater. That is to say, within the initial 10 seconds, the voltage on your water heater will be measured. It gradually increases from 0 to reach the level of the network with smooth progression. The water in your water heater possesses resistance. Therefore, as the voltage increases, the current also increases due to the resistance in the water. Data regarding the increasing current transformer, and current sensor are transmitted to the microcontroller for viewing the value, as well as to the current stabilizer for further analysis and control. At present, there is a handle located within the stabilizer that is currently being utilized for its intended purpose. This is the pen. Using this pen, you can set the current limit in advance, such as 15 amps. Thus, when the current reaches this level, it will take effect immediately. The stabilizer will prevent any further increase in current, effectively stopping any additional rise in voltage on your water heater, ensuring its safety and optimal performance. In addition, the current will be stabilized at this level until the stop command is received from the microcontroller unit. And as a result, you are no longer concerned about such problems as the increase in water electrical conductivity with temperature rise, low voltage in the network. In case of any water leakage, you have the option to refill the heating system to ensure its proper functioning and efficiency. The current will stay stable at the level you have previously set, without any fluctuations or changes. Stabilization process can be graphically represented. Here are the initial few seconds of the KROS operation after receiving the heating command. This represents the growth of our current. Now let's examine it more closely. Somewhere within this time frame, our 15 amperes gradually rise to 15 amperes, and then the current stabilizes at this level for the remainder of the operation. Let's simulate two scenarios. Raising the water temperature increases its electrical conductivity. The current is starting to rise. However, the current sensor immediately detects it and forces the current stabilizer to attach our knob with voltage in order to maintain stability. The second situation, on the contrary, you have made repairs, added 2 more radiators, or maybe underfloor heating. We made a water supply. It turned out to have a lower electrical conductivity than all the water that is already filled in your system. We won't encounter any problems again because the sensor will detect a decrease in the actual current, prompting our voltage stabilizer to open our voltage regulator more and ensure stable voltage output. However, is there a reserve for this additional opening of our voltage tap? And here, as they say, there is no bad without good. In our system, we have tap water available. The electrical conductivity level of tap water in different cities across Ukraine ranges from 600 to 1200 microsiemens, 1.5 to 3 times higher than necessary for an electric water heater with automatic control on a contactor. This is not ideal for an electric boiler as its power output can exceed the recommended limit by 2 to 3 times. In order to use the boiler, the electrical conductivity of the water must be reduced to the required level. However, for a KROS, this excess power serves as a reserve in our tap, ensuring full heating capacity even with a substantial decrease in the power supply voltage. Now I will explain. And at the same time, by the way, I will fulfill the promise made in the video about the disadvantages of electric water heaters. I remind you that a disadvantage of a conventional water heater is that when there is cold water in the heating system, the boiler only uses half of its power, so it takes a very long time to heat up a cold house, or it may not be able to reach its rated power at all. In that video, I specifically mentioned that KROS completely eliminates this particular drawback. How? It's simple. You can easily set the maximum current for your water heater by using a KROS pen. Once adjusted, the heater immediately starts operating at full power, providing you with hot water. Due to the high electrical conductivity of tap water, this feature is provided for better performance. As an illustration, based on the information in your passport, your electric boiler is rated at 4 kilowatts of power. According to the same passport, it is indicated that the power will be effective within a temperature range of 60-70 degrees Celsius. That is when the conductivity of water in the system reaches 800,000 microsiemens. However, our tap water is already cold and has sufficient electrical conductivity. As a result, the boiler immediately starts operating at maximum power and efficiently heats your home. To achieve this, our current stabilizer allows you to adjust the current to 20 amps using a knob on the KROS. This is ideal for your 4 kilowatt boiler. The power at 220 volts in the network is calculated to be 4.4 kilowatts, obtained by multiplying 220 by 20. Despite the increase in water temperature, the current stabilizer will keep the current at a consistent 20 amps by reducing the voltage supplied to the water heater. This ensures that the power remains stable and prevents any potential damage to the electrical system or the water heater itself. If you measure the voltage on the water heater at 60 degrees, you will see 140 volts. Multiply it by the current of 20 amps on the display, and you get 2.8 kilowatts. Yes, this is the current power consumption that is being measured and recorded at this very moment. During the cold start, your boiler consumes 4.4 kilotariff. As it heats up to the desired temperature, it reduces power to 2.8 kilotariff. This reduction is achieved using the KROS, which helps optimize energy usage. This is another amazing feature of the AutoKROS, which operates fully automatically. We avoid applying excessive load to the network when turning on and off. Instead, we load the exact amount necessary to maintain the desired temperature, ensuring efficiency and optimal performance. You have the flexibility to modify the load level by conveniently rotating the handle located on the front panel of the KROS at any given moment.